How can I use algebraic properties to prove equations? Imagine you are solving a puzzle where each step must follow a rule to make the pieces fit perfectly. That's what using algebraic properties is like when proving equations. It's about showing that two sides of an equation are equal by following clear, logical steps. First, you start with what you know, like an equation or expression. Then, you pick a property to apply. For example, if you see addition on one side, you might use the addition property of equality. This property says that if two things are equal, you can add the same number to both sides and keep the equality true. Another common property is the reflexive property, which simply states that any quantity is equal to itself. It's like saying A equals A. This is often your starting point. The symmetric property lets you flip an equation around. If A equals B, then B equals A. This helps when rearranging equations. The transitive property connects equalities. If A equals B and B equals C, then A equals C. It's like linking chains together. When working with equations, you often need to add or subtract the same number from both sides. The addition and subtraction properties of equality make this safe. For example, if you have 3x plus 5 equals 11, you can subtract 5 from both sides to get 3x equals 6. Then, dividing both sides by 3 using the division property of equality shows that x equals 2. Multiplication and division properties are similar. If A equals B and C is not 0, multiplying both sides by C keeps the equality. Dividing both sides by C also works, as long as C isn't 0. The commutative property says that changing the order of addition or multiplication doesn't change the result. For example, A plus B is the same as B plus A. The associative property means you can change how you group numbers without changing the sum or product. For example, A plus B plus C equals A plus B plus C. The distributive property is very useful. It says that multiplying a number by a sum is the same as multiplying each addend separately and then adding. For example, A times B plus C equals A times B plus A times C. To prove an equation, you start with what you know and apply these properties step by step. Each move must be justified by naming the property used. For example, if you want to prove that to x plus for x equals 6x, you can show that to x plus for x equals the same as to plus for times x, which simplifies to 6x. This shows the original statement is true. In formal proofs, you write each step in order, explaining which property you used. This makes your reasoning clear and shows that each step follows the rules of algebra. Using algebraic properties, this way helps you understand why equations work and how to manipulate them confidently. It's like having a set of tools that make solving and proving equations straightforward and reliable.